All right, ladies and gentlemen. Okay, so what we're going to try to work on today here, I'm going to try to see how this goes. We're going to try to do some recording on the iPad. Hopefully that works out well. We'll see how the quality is, but we're going to look at today phase shift still. Now remember, what's phase shift? Phase shift is really what again? Horizontal, left or right, what? Movement of the curve. Okay, left and right movement. It's horizontal shifting. So what I want to remind everybody here, we're going to look at the tangent and cotangent. Now remember, tangent and cotangent, the period is what? It's different. It's pi over what? It's pi over k. Are you guys okay with that? So it's pi over k now. That's a little bit different, okay? And so recall the interval of one cycle here. Oh, that's a different worksheet. Yeah, we're going to have to now do this. That's not the phase shift worksheet, but let me go back. And let's actually take a look online if we can do that here. There we go. That's the one we're working with. Phase shift. Still has the same period, just so you guys know. And I'm going to create a new note, and we're going to highlight and emphasize this. Okay. All right, so phase shift here, okay? Same period as before, not for sine and cosine, but for what? Okay, you can see that there? Pi over k for tangent and cotangent. Now, remember what we talked about yesterday. That's extremely important here. You see, you have to have, and you will have the k value for both of these. And then the phase shift has to have that minus sign there. Is that true? This is what I want to make sure people don't get confused with. Okay, because this is traditionally where people get confused. It's x minus this b is the phase shift value, okay? So that's important. When b is positive, you're going to shift the curve to the right. When b is negative, it's shifting to the left. But be careful here. It has to be a b value after that minus sign. So we're going to look at that detail. Also, remember, the interval of one cycle now is about shifting everything over now. So for tangent, this is your interval of one cycle. And then for cotangent, here's your interval of one cycle here. Okay? Scroll up. There we go. Remember, do you have and again, b is that phase shift value. Do you have an a value by any chance? You do have an a, but this is not the amplitude. Remember, for tangent and cotangent, you don't have an amplitude. Okay? So this is the information we're going to use to start sketching these curves here. Alrighty? And again, this is all from, if you guys remember, so from my website here, the Trig worksheets here. And it's actually in Canvas for you guys as well. So anyway, doesn't seem to get there as nice as we want. But okay, let's try to do the first one here. All right, you guys okay with that? We're going to do the first one here. Now remember what I just said, because we're going to go out and I'm going to say this is tangent x minus pi over 4. So let's go out over here and we say, let's kind of work with that one. So y equals tangent x minus pi over 4. Is that right? Okay. And that was like number 1. So we're going to try number 1 there. So as you guys read this, you might say, hey, where's the a value? Well, the a value here is here. It's 1. It's not really that important for us to sketch. It's not even an amplitude. And then you say, but okay, where's the k value? What's the k value by now? It's 1. Good. You guys know what that is. There's like a 1 there. That's going to be useful. And then do we have x minus? Be careful. It needs to be minus. What value is this? That's your b. Okay, so that's your phase shift. So, ladies and gentlemen, that's kind of the information you always want to start with. Is that right? Okay, you guys know what I'm saying? Now, here's the deal here. We're going to use not the amplitude. We're not going to start with the amplitude because there is no amplitude for tangent and cotangent. Okay, so there is a period though. Now, be careful with this period. What's the period for tangent and cotangent? It's pi over what? It's pi over k. Is that true? And then what is k? K here is what? 1. So my period here is pi over 1, better known as what? Pi. So there you go. That's my period. Okay, you guys okay with that? This is not sine, it's not cosine. Don't say 2 pi over k. Now, what's the interval of 1 cycle again? If there's no shifting, remember this. I want you guys to note this. I'm going to put it as a note because this kind of helps me in a lot of ways. I'll say, no, if there's no shifting, it's pi over 2k, negative pi over 2k to pi over 2k. Is that right? But because there's a shift, all you do now, there's a phase shift, all you'll do now is insert your b value. So it'll be b minus what? Pi over 2k, and that'll be b plus what? Pi over 2k. So what's your b value here? It's here and here. Okay, now that's not your period though. That's pi over what? 2k. So we already know k is the value of 1. Is that true? So we say, okay, k is 1. We know that. So what that means is, and then b, oh yeah, b is pi. Let's put that there. Okay. So our interval of 1 cycle will be pi minus pi over, what's 2 times 1? Is that 2? Pi plus, what's 2 times 1? Is that 2? Okay. So we're working here with all of that information. It's just now, what do we have to do again? You guys remember that dreaded word called what? Arithmetic. We're going to have to take a whole number like pi. It's not even a whole number. It's an irrational number. And it has to have the same denominator. So what are we going to do? Do you guys remember? What are we going to do here? Anybody have an idea? What are we going to do? How are we going to do the arithmetic? By now, you guys should be experts. 2 over what? 2. 2 over 2. Why? Because you have to have the same what? Denominator. Okay, so now what's your interval of 1 cycle going to be? 2 pi minus pi gives you what? Isn't that pi? Excuse me? Oh, excuse me. Did I make a mistake? I'm sorry. I'm so sorry. I got to get this coffee in me. I'm glad you guys are awake. It's pi over what? 4. Good job. Let's go back. B is what? We didn't even write it down. B is pi over 4. Outstanding. Good for you guys. Oh, my God. So that's going to change our arithmetic. Okay, so it's pi over 4. Okay, thank you guys for noticing that. We got to wake up. We're still going to now have to do the arithmetic, though, right? So let's kind of remember this. What do we do now in terms of the arithmetic? Do you guys know? Thank you. Not even awake. What do we do? Which one do we multiply by 2? Yeah, here. Okay? So we get pi over 4 minus 2 pi over 4. Pi over 4 plus what? 2 pi over 4. What's pi over 4 minus 2 pi over 4? Is that negative pi over 4 and then pi over 4 plus 2 pi? Isn't that what? 3 pi over 4. Okay, you guys okay with this? All right, now I would say to you in all honesty, this to me is really going to be your key to graphing. Okay, I'm going to call that the key. Now notice again, you have an open interval here. So why is this the key? Okay, so when you start to sketch this curve here, ladies and gentlemen, this is only one cycle. We're going to have to locate what? Negative pi over 4 and what? I'm going to do a 3 pi over 4 here. Okay, you guys okay with that? It's because this is where you start and this is where you end. But what kind of function is this again? What function is it? This is tangent. So what do you guys know about tangent? This location over here is a what? Vertical asymptote. This location over here is another vertical asymptote. So what they're going to ask you, as you guys notice, is I ask always, hey, where's your vertical asymptotes? They happen at x is minus pi over 4, right? And they happen at x is going to be what? 3 pi over 4. What you always need as well is the x-intercept. And then you say, well, where's my x-intercept? You guys know where that x-intercept is? It has to be midway. It's midway, and you know, maybe you want to try to mark it midway somehow, but where's midway? What's in the middle? What is it? How do you know without finding that midway, without going through the arithmetic? Can you say, Mr. Judge, can I take pi over 4 plus 3 pi over 4 and then divide by 2? I think we get 2 pi over 4 divided by 2, right? Which is pi over 2 divided by 2. You get pi over 2 times 1/2. And yes, you're right. It's pi over what? 4. Good. So can you do this? Yes, we can do it. But what do we notice about the tangent curve here? Do you guys remember? What do we know about tangent? So if I go to Desmos, generally speaking, tangent, like we said before, well, this is an interval of one. This is not an interval of one cycle, right? Interval of one cycle for the tangent curve, generally speaking, is going to be, let's get out the parentheses here. I can't find it, so I have to guess it's over here. Do you guys remember? Isn't that going to be negative what? Negative pi over 2 less than or equal to x, less than or equal to what? Positive pi divided by 2. Okay? That's your interval of one cycle. That's your tangent curve, and it goes through the origin. So if you said, well, what happens if I shift that? Remember what we said? It's x minus. You have to have x minus what? This example is pi over what? 4. Okay? How did we shift this curve in red? It went to the what? To the right. How many units? Pi over 4. So my point is to you guys here. You see that's the origin, and this is what? Pi over what? 4. Yes, it's in blue. You got more than one cycle. But my point is, this sure enough is a what? a right shift pi over 4. Okay, that's my point to you guys. So that origin moved to the right pi over 4. You guys want to think of it that way. So it is a right shift. And so now you get to do some what? Sketch the curve. Never cross your vertical asymptotes. Is that right? And now, ladies and gentlemen, you're done. There it is. Okay? So this is how you handle the shifting for what? For tangent now. But be careful here. The key is right in here. Get your interval of 1 cycle. That's the key. And you must use the right what? Formula for the interval of 1 cycle. So, you know, one thing that you can do, and one thing that I do is, in all honesty, is what do I do? Every time I do a question, I write it all down, same way. So like for number 3, if you guys can check, right? You say, well, where's number 3? I think it's here. Oh, let's do a what? Cotangent. Cotangent x plus pi over 6, or if you want, yeah, we could do the cotangent now. What do you guys remember about cotangent, though? Go back over here. It has the same period. You got to have x minus that b value, but what's your interval of 1 cycle for cotangent? Do you guys remember? Without a shift, with no shift, what do? It was 0 to that period. That's with no shift. But because you have a phase shift value of b, what do? There's b, there's b. So b is going to be involved. That's the phase shift. And it's going to be b plus p. Okay? So with a phase shift of b value, we have a different interval of 1 cycle. So this is cotangent x plus pi over 6, number 3. And then I'm going to remind you guys, right in here, you don't have minus, do you? And again, watch out, because this is where people make their mistake. You don't have minus. You need minus. How do you make that minus be there if it's not there? Minus the minus makes you a what? Positive, okay? So this question now really is going to be y equals cotangent. Do you guys have the minus there now? Say yes. What's your b value going to be? Anybody know? I wish I had my sound effects. What's the b value? What is it? Yeah, you guys see what I'm saying? So now, very clearly, we know the phase shift value is negative what? Pi over 6. There's your phase shift, ladies and gentlemen. Okay, there's the phase shift. What kind of shifting is it? Right or left? Left. Good job. It's a left shift. Why? How do we know it's left? It's negative. Okay, what's k here? Because remember you said we have to find the period. Every time I use my formula, I write it down. This is going to be cotangent. I have a different period formula. It's pi over k. I need k. What do you guys know about k? What's k?
1.
You say, isn't there supposed to be a k here, Mr. Judge? Yeah, there is. K is what, though? 1. So if k is 1, goes here, here. What do we know about the period? Period is pi over what? 1. What's pi over 1? Pi. There you go. So, okay, now be careful here. This is a cotangent curve. We need the key for our graphing, which is that interval of one cycle, that restricted domain. So that's going to be B plus what? P. Now, let's try not to make a mistake like we did before. Hopefully some of this coffee's kicked in. So, negative pi over 6, negative pi over 6 plus, what's your pi? Your period is pi, right? Okay, you guys okay with that? Notice, I don't think we made a mistake. Where's our P now? There we go. Okay, we're okay. Now we just have to do our algebra here. Okay, the left side, we're fine. We're fine for the starting point's okay, right? Where's the ending point, though? Negative pi over 6 plus pi, what's that going to be? Well, yes, because you have to have a 6 over 6 to do the arithmetic. Is that right? It has to have the same denominator, right? You have to have that same denominator here of the 6. So negative pi over 6 plus 6 pi is negative what? Negative 5 pi over 6. There you go. This is the what again? That's my key, in all honesty, ladies and gentlemen. Oh, positive. Sorry, that's my key. Okay. Negative pi plus 6 pi is positive. So remember what I do here with this? Whenever I have a negative, I started a negative value here, okay? What I'll do personally is I write this negative pi over 6 here. And I'll put the positive 5 pi over 6 over here, because that's where you start, that's where you end, right? That's your key here, your starting point and your ending point. Yes, this is cotangent. So that means that these are the locations of our what? Of our vertical asymptotes. So you guys want to do that there. You want to write that down, your vertical asymptotes here. And then you need a midpoint. You say, where's my midpoint? You guys know, where's that midpoint going to be? Well, maybe you want to add and divide by 2. So negative pi over 6 plus what is this here? Add them, divide by 2, right? So negative pi over 6 plus 5 pi over 6, what's that going to be? Is that 4 pi over 6? Don't forget to divide by what? 2. Isn't that 4 pi over 6 now times our what? 1/2. 2 goes into 4 twice. So you say, I have 2 pi over 6, which gives me what? Pi over what? 3. Okay? Pi over 3. Now, just doing the arithmetic. And remember, don't ever be ashamed to do an arithmetic. We all need the practice, right? But now you say, but where's the y-axis on this thing, right? Well, what do you guys think? Where would the y-axis be? Isn't it to the left here? No, the x-axis is here. Where's the y-axis? How do I know the y-axis is like somewhere over here? Do you guys know? And in fact, I know it's midway, but how do I know it's to the left? Well, because this is negative pi over 6, and this is positive pi over 3. Is that right? So isn't it in between? I think so. So, okay, now I could label my y-axis. What curve is that, though? This is what? Isn't that cotangent? Now, remember what I said about cotangent. What do you guys want to remember here about this curve? What's the graph look like? Negative x cubed. Negative x cubed. That's my memorization device of this. And negative x cubed is like x cubed, but it's reflected about the x-axis, right? So that means it looks like this. All right, ladies and gentlemen, there we go. What do you guys think? Easy peasy, the phase shifting? So if you look at the phase shifting you did yesterday, it was different curves, sines and cosines. It's the same exact idea, and then it does come down to arithmetic, but you have to know what curve you're looking at. Sine, cosine, tangent, cotangent. Yes? What's that?
The curve.
Thank you. Yes, thank you so much. This is the x cubed curve. What do we have to graph? Minus x cubed. So we have to reflect this about the what? About the x-axis. Thank you. Good job. I think I need to go have breakfast or something. Take the day off. Have you guys do it and have breakfast. But all right. Number 5. Oops, I'm looking at the wrong place. Okay, now we're going to get a little bit exotic. Cotangent 4x plus pi. We're going to get a little bit exotic, okay? So this is kind of now number 5. Y equals cotangent, what was that? 4x plus pi now. So now this is just like yesterday, okay? What was this value in front from yesterday? You guys remember? This is the k value. What do you guys have to do? Factor out what? Factor out k. Good. So we're going to have to write this as that k. K is 4 now. Okay, so okay, k is 4. I have to write it as 4 times a quotient. Is that true? You guys remember some of that factoring we did? I forget what color. I don't know. I'm going to have to use, brown or gold or. How do I get the quotient again? You take what? 4x plus pi, you divide by 4. That's the k value, right? And it's the same k value. Of course, what's going to always happen is that first coefficient is going to be what? 1. So this becomes x plus what? Pi over 4. So altogether, we have cotangent 4 now. There's my quotient. This is what I replace here. That's the q. That goes up where? Right in there. So you're going to have now x plus pi over 4. Okay? You guys okay with that? That's why we did that factoring yesterday. A little bit about that factoring. What do you guys think you do here? Anybody know? You can't have plus. What do you need? You need minus, don't you? So you have x minus a what? Minus pi over 4. Okay. All right, ladies and gentlemen. Now, what do you guys think we do? Yeah, we're going to have to do what now? Identify everything. Okay, this is what? This is K. What's this? Here's my phase shift. Okay. So I guess we're going to have to start with the period, right? So period is pi over what? K, which is really pi over what? Pi over 4. There's my period. My interval of one cycle, oh, what curve is this? Is this cotangent? I got to have the right interval. What is this? B plus P. So that interval of one cycle becomes, what's the B value? Negative pi over 4. This will be negative pi over 4 plus my period of positive pi over 4. Is that right? So I'm going to make sure we use everything we're supposed to. B, negative pi over 4, negative pi over 4 plus that, what, P. Okay? So here's my interval of one cycle. What's it going to be? Negative pi over 4 up to, what's this? 0. All right, you guys okay with that? Now remember, what do we say about this? Isn't this the key, ladies and gentlemen? That's your key. Okay. Now, you might say, but Mr. Judge, why did you draw the y-axis now? Well, you know what I'll do? I'm going to move it all the way over here. How's that? So my interval of one cycle goes from negative pi over 4 up to what? 0. So what I'll do is I'll put negative pi over 4 over here. Okay. I put 0 over here. Now, what do I do with these? Draw the what? Oops, sorry about that one. You guys okay with that? What's midway? Because remember, tangent and cotangent, this curve is what? Oh, is it cotangent? Yeah, it's cotangent again. So this curve is going to go through that point. Is that right? What is that location? What's the location there? Because remember, we want to, vertical asymptotes happen at x is negative pi over 4 and x is 0. And I think we have to do it for the last one as well. The x-intercept, where you hit the x-axis, happens at x equals, what's it going to be? Huh? Is it negative pi over 8? I think it is. Are you guys learning how to do that? Good job. Nice. Outstanding. Negative pi over 4 plus 0 is negative pi over 4. Divide by 2 is really taking negative pi over 4 times 1/2. Negative pi over 8. And let's not forget again, like we did the last time. This is going to be what curve again? Cotangent. I might even put it in red. You say, why would I put it in red? I'm going to remind myself because, you know, red's kind of an interesting color. Is anybody here, your favorite color is red? My favorite color is blue. I like blue. Anybody like blue? Good. But you want to know something? All my cars are red for some reason.
How many are they?
Well, I mean, the cars I've had, I only have one. When I buy a car, I don't know why I get red. It's the worst color to get. But red makes you what? It stands out. So I would say get that red marker, that red highlighter, because sometimes it helps you remember a lot of these details. Red's something that makes you remember. Huh?
Sorry, the scene of a crime.
Scene of a crime? Now, where's the extinguisher at? Let's write that down. Negative what? Pi over 8. Yeah, it's kind of it's an amazing color. I don't know. There are studies on the color of red, just so you guys know. Okay? So you say, the people study the color red. Red's kind of an aggressive color, though. I have a friend, he has well, what did he do? Do you guys know where the Venice Room is? Maybe you don't know. You guys don't know. You're kind of young. Anyway, the Venice Room, his wife's family used to own the Venice Room. Used to, not anymore. So he helped her manage it. He always told me, I knew who was going to get in a fight, on a particular night. It was the guys that were dressed in what? Red. It's aggressive. So they had a red tie or a red shirt. I guess back then people wore red. Guys wore red. Do they wear red these days? Maybe not. I don't know. It's kind of an aggressive color, red. All right, anyway. Number 7, -4 tangent. What is this? Can you guys help me remember? -4 tangent 3, x minus pi over 2. Y equals -4 tangent 3. Was it minus pi over 2? Is that what this was, ladies and gentlemen? Okay. All right, let's go through this. I mean, since this is tangent, that's not an amplitude again, right? Tangent and cotangent do not have amplitudes, but that's going to be significant in the graph, that first number, where it's going to be reflected about the x-axis. So, okay. Now, what about the 3? What's that? K, good. And do you have a minus? Yes, that's great. What does that mean? B is what? B is pi over 2, ladies and gentlemen. That's your B value, your K. I mean, you can call it A. I did in the worksheet, but it's not an amplitude. We didn't define that as an amplitude. So, okay. Huh? It's a negative coefficient, and in fact, again, I mean, you say, what about, is it a factor in the curve in the graph? It actually is. It's not just reflected about the x-axis, but it can make the curve, depending on the constant, skinnier or wider. Okay? Now, you say, do I need to care about that for my sketches? No. Because you're sketching. But, if you look at the details of it, yeah, it'll be either a skinnier, negative tangent curve or a wider negative tangent curve. But for our sketches, it's not important. What's the period for tangent? Pi over what? K. All right, what's K? 3. And I already know my fascia value is what? Pi over 2. So what's the interval of one cycle, ladies and gentlemen? For tangent now. Uh-oh, it's been so long that we've seen tangent, we may have forgotten. Interval of one cycle for tangent, ladies and gentlemen. Where is my tangent curve? There we go. It is B minus pi over 2k. And then B plus what? Pi over 2k. Okay, because remember, without the phase shift, it's just minus pi over 2k and positive pi over 2k with no phase shift. But because you have the phase shift, you got to insert the b for both of those values here. So be very, very what? Careful. Now, remember, you guys, I'm trying to record this on the iPad. We're going to see how that video quality is. So I'll send it to you guys. Have you guys been getting my PDF files and the announcements for the lectures, I hope? Okay, so I'm going to try to record this as a video with the iPad and the audio. Let's see if it comes out. And if it works well, oh my God, who cares if that laptop crashes? We just don't have the audio, I guess, but okay. All right, where are we at? Here we go. B minus pi over 2k, and then b what? Plus pi over 2k. All right? And I'm going to move everything over here. Okay, so I'm going to put some color here. So maybe that stands out, but I can't use the orange, but I can use my purple because my k value is here and here. What's k again? What's k? 3. Good. So, okay, let's see what we get for that interval of one cycle. B, pi over 2 minus pi over, what's that going to be, ladies and gentlemen? What's 2 times 3? 6. Good. And then again, b now, okay, which is pi over 2 plus pi over what? 6. Okay? Okay, what kind of arithmetic do I do now? Huh? Multiply by 3 and 3 to get your common denominator. Yes, outstanding. What do you guys think? Are you starting to really, as you see this over and over again, the drill and kill idea, right? Is the arithmetic becoming easier, ladies and gentlemen? What do you guys think? Yes is the answer. That's the idea. And again, like I said, I always have said that even when I was a student, you know, when I've taken these courses as an ELAC student myself, right? Doing all that arithmetic, yeah, very helpful, very helpful. So you're not alone if you say, oh my God, I got to practice my arithmetic. Not alone. You know, you keep doing it, you get better, better, and better. It's not a wasted time of investment. You're not missing anything on Netflix. Netflix is boring, right? No? Disney Channel's boring. No? I don't know. What do you guys watch on Netflix? Is there anything good? I can't find anything good. It's a waste of money. Cancel your Netflix. Can't find anything good there. I don't even think they make good movies anymore. What do you guys think about that? Yeah, that's an old man. Old people say that stuff. 3 pi minus pi, isn't that what? 2 pi over 6? 3 pi plus pi, isn't that what? Is that 4 pi over 6? Pi over what? 3, and then 2 pi over 3. Yeah, I think my daughter told me the other day, she says, Dad, you got to watch this movie Smile. I go, Smile? Yeah, she says it was creepy. I don't know what it's on. I don't know what it's on. You guys watch that movie Smile? Was it scary? That's what she says. It's really creepy. You know what? You know, I start to get scared now. You never used to. Never used to. Then I started watching some of these shows. I'm like, oh my God, it's kind of scary. Isn't that funny? Never got scared. Now I do. Let me double check. I don't really get that scared. A little. Okay, isn't that the key again? You guys know what I'm saying? Where's your pi over 3? Isn't that to the right? Then I go all the way out here to what? Is that 2? Is it 2 pi over 3? We do our arithmetic okay? All right, what's this location here? These are all my vertical asymptotes. So again, if you're taking a 260 course, they really go through that vertical asymptotes. So I want to do it too. So I'll ask you guys to label that. I'll even ask you to tell me what the what is. The x-intercept. What's your x-intercept, ladies and gentlemen? What's that going to be? You add them and you divide by 2. So pi over 3 plus 2 pi over 3, isn't that 3 pi over 3? What's 3 pi over 3? Pi. And then divide by 2. Pi over 2. So after you do enough of these, you're able to kind of do that. You guys know what I mean? After you start doing a lot, you go, all right, I can do this already. So you're practically done. We're going to label that x-intercept pi over 2 here. And I'm going to remind you guys, we got to go back here and look at what? What is this? Yeah, let's be careful here. Tangent is what? Is x to the third. Remember that? But the minus sign is going to be minus what? X to the third. It's not cotangent though, but it's... Okay, you guys see my point? That a is negative there. So when a is negative, we got to reflect x to the third about the x-axis. That means it's minus x to the third. Okay, so I'm just going to kind of put that here to remind you guys, minus x to the third. And alrighty, let's make sure we do what? Let's sketch this. And there you go, ladies and gentlemen. That's how we do this process. What do you guys think? Is that okay? Which number was that? Number 7? Alrighty. What do you guys think? Is that okay? Number 9. We're now going to say 1/2 cotangent of 1/3 x plus pi. Okay, now what I'm going to do here is this. You know, you might say, am I going to label that A? Well, I guess I could, but graphically speaking, when I sketch, it has no value again. This isn't sine or cosine. K value. And then, oh yeah, what's the deal here? Do you guys remember? Yeah, you see that? I gotta write it as what? X minus a minus pi. So by doing that, I can identify my phase shift. What's the phase shift, ladies and gentlemen? Negative pi. Is that true? Okay. All right. Period is pi over k. And oh, I get to do some nice arithmetic. K here, ladies and gentlemen, is 1/3. So what's pi divided by 1/3? Do you guys know? You can say it's pi divided by 1/3, or pi times 3/1. What is that going to give us? 3 pi. Okay. Nice. Okay. Okay, you guys okay with that? Did we get you with that constant 1/3? That's why I did it. So anyway. Okay, ladies and gentlemen, my interval of one cycle, be very careful now. This is where you have to be careful. You got to have the right interval of one cycle. Is that right? So what function is this? It's cotangent. What's the interval of one cycle for cotangent? B. Isn't it B plus P? Do you guys remember that? I highly recommend, like I said, I was a high school student. You guys already know. I never studied, and then I had to learn how to study. And then, how did I do that? Every time I used a formula, I wrote it down because I wanted to remember it. And then sometimes I even used flashcards. I did both sometimes. Okay, so it's very helpful. So now, and I'm even saying this to you guys, get some highlighters. Wrong color. This is helpful too. That's only if you're a student like me that has to learn how to do some what? Homework and study. So negative pi plus what? 3 pi. Is that true? So, I would even rewrite my notes with that kind of system, personally. And okay, here we go. My interval in one cycle is going to be negative pi up to, what's negative pi plus 3 pi? 2 pi. Easy peasy lemon squeezy. This again, did we do our arithmetic okay? Yeah. Number 9, okay, now, remember, when we start to sketch this, what are we gonna do here? Yeah, this is gonna go from negative pi up to what? 2 pi, okay? So can I ask you guys a question here? How do I find, since remember, you say, where's my y-axis? I don't write it down yet. Because I need midpoint between what? What's midpoint between negative pi and 2 pi? Well, add them. Negative pi plus 2 pi is what? Pi divided by 2. Is that pi over 2? So what I'm going to say is your y-axis is somewhere between what? The negative and positive value. Okay, you guys okay with this? There's your x-axis. Oh. So I'm using this important information. Now, what do we do here? We got to go back and say, oh, what curve is this again? Cotangent. What's the memorization device for cotangent? Negative x to the third. So you get to sketch negative x to the third here. Oh, we forgot to do our vertical asymptotes. I'm just getting ahead of myself. Vertical asymptote, vertical asymptote. It's good to summarize it. Okay. Happens when x is negative pi. Happens when x is 2 pi. Okay, where's the x-intercept? Pi over 2. And then we get to sketch the negative x to the third. Has to go through that x-intercept. So negative x to the third, oh yeah, it looks like this. I got to remember. So ladies and gentlemen, there you go. Easy peasy lemon squeezy. All right, good. All right, now.
Wait, what was it again? Sorry, was it reflected as right? Was it negative 1/2 cosecant or something?
What's that?
What was the original problem? Sorry.
It's okay. It's right here.
Oh, cosecant.
Now, isn't this all the things that we've been working on and looking at? Number 11, you know what I'm going to do, ladies and gentlemen, number 11? When I get home, I'm going to change number 11 because I'm going to put it as a positive. I'm tired of doing negative x cubed. I want to do a positive x cubed. So number 11, I'm going to change that on you guys. I'm going to make it positive, okay? And I'm actually going to change this too. I'm going to say, I'm going to make it negative pi over 6. Just for fun. So what I'm going to have to do here for myself, because if you look at the worksheet, number 11 here. So, Mr. Judge, did you just change that one? Yeah, I changed it on you. I got to remind myself. When I get home, let me change number 11, you know, because I'm tired of doing I want to give you guys a little bit more variation. Let me take a picture so I can remind myself. Number 11, we're going to change, okay? I'm going to do this one instead for fun. Now, you might say, where's the A value here? It's right here. Here's A. Does it have any meaning in a sketch? Well, it's just as the regular tangent curve. It's not reflected. It's not an amplitude. K is 1/2. Is that right? And then minus. Do you have the minus there? Yes. So B is just pi over 6. That's my phase shift, ladies and gentlemen. So, you know, I just kind of wanted to do a straightforward kind of question, in all honesty. You guys know what I mean? Okay. What's your period again? Period is pi over k, and what that means is my period is going to be what? Pi over 1/2. Don't forget. Pi. This always helps me. To write this as what? You guys know what helps? Write it horizontal. Yeah. Because I was one of those students that say, what do I do with this? Oh, okay. Flip this over. Now that's 2 pi. So, ladies and gentlemen, oh, okay. There we go. I got my period. Phase shift is pi over what? 6. Now this is tangent again. All right. Anybody memorize that here with a phase shift and tangent? Normally with no phase shift. This is no phase shift. But we have a phase shift. So you go, no, not that one. We have to use the what? Insert your B. B minus pi over 2k, and then B plus what? Pi over 2k. Okay? So I just want to let you guys know, insert the B there. Use the right phase shift.
We are confused. So why is it like different, I guess?
Why is it different?
Interval, like I think some of them are like B, so like I don't know, like some of it's like
Because of the curves are shifted differently. If you go back to the cotangent curve and the tangent curve, tangent is, it goes to the origin. And then the period, again, is pi over k. So to the right, half from 0 to pi over k is pi over 2k. Then minus, you know, let me rephrase that. The period is pi over k. That's the length of one cycle without looking at that. And so half of to the right, half to the left is where you get pi over 2k minus pi over 2k. Now, when you have the phase shift, you got to insert B for both the starting point and the ending point. So that's where you get this new formula here. But, okay, what's K? So in other words, you already know B. It goes right in here and here. So B is going to be what? That's pi over 6 minus pi over 2. What was K? K is what? Yes. So this is times 1/2. Pi over 6 plus pi over 2 times the K value. So remember, K. So what is 2 times 1/2? Isn't that 1? Is that 1? 2 times 1/2 is 1. You guys okay with that? You guys see what I'm saying right up in here? The 2 times 1/2. Because k is 1/2. So 2 times 1/2. Okay. Now what do you guys have to do with the algebra, right? 6 over 6. 6 over 6. Why? Same denominator. You got to have that same denominator to add or subtract. So we have pi minus 6 pi. What does that give you? Is that negative 5 pi over 6? You got pi plus 6 pi. What does that give you? 7 pi over 6. Again, you have the what here. This is going to be your what? Your key. Okay, you guys okay with that? So this is the arithmetic behind it all. And okay, so now, ladies and gentlemen, remember, since you start at a negative, I'm going to pull it all the way down here. Yeah. Since we start at a negative, I'm not going to put my y-axis. What I'm going to have to do is say, okay, negative 5 pi over 6, you have that vertical asymptote, up to 7 pi over 6, another vertical asymptote. But we need to know what is midway, right? We got to find the x-intercept. So what do you think you guys do to find that x-intercept? Okay, let's add them, divide by 2. Negative 5 pi over 6 plus 7 pi over 6, what is that? Isn't that going to be 2 pi over 6? And don't forget to divide by what? 2. Is that true? Is that 2 pi over 6 times 1/2? Which gives you what? Pi over 6? Okay. You guys know what I'm saying? Is that okay? Is that right? Double check, because I haven't even finished my coffee. All righty. Now you might say, Mr. Judge, where am I going to put my y-axis here? Well, you know, what do you guys think? Is the y-axis closer? Is it in the middle between negative 5 pi over 6 and pi over 6? Or is it closer to pi over 6 than, you guys know what I'm saying? Where's the y-axis? Where is 0 closer to? I'd say pi over 6. So even though this is just a sketch, I'm going to try to put it a little bit closer to what? You guys see my point? It's just a sketch. You might say, Mr. Judge, I want it a little bit more closer. Okay, then that's fine, but it's just a what? It's just a sketch. You have really all the important pieces of information to sketch. What do I mean? Vertical asymptote. Vertical asymptote. Where do the vertical asymptotes happen? X is negative 5 pi over 6. And then x is what? 7 pi over 6. And then what's your x-intercept? X is pi over 6. So don't forget, what kind of curve is this, by the way? It's just a regular old what? Tangent curve. Bread and butter tangent. No reflected about the x-axis. All right, with tangent, what do you guys remember? Just think of x to the third power. Okay? And then now, we get to finish that curve. And there you go, ladies and gentlemen. Easy peasy, what? Lemon squeezy here. And there it is. What do you guys think? Is that okay? Anybody have any questions on this one here? That one okay? Should we have you guys try one? Give you guys a few seconds to try one yourself, a bonus. What's a bonus? Give you guys a little bonus. I said, Mr. Judge, that's not a bonus. Y equals secant. Do you guys recall, what's the reciprocal of secant? Cosine? I want you guys to note here. What does your cosine curve look like? Consider this. What's the period for cosine? It's 2 pi. What's the interval of one cycle for cosine? 0 to what? 2 pi. Is that true? You guys with me on that? So, if you know how to graph cosine, this is something important. I think for cosine as well, what did we forget? What's the amplitude?
1.
In this case, the amplitude is 1. Is that true? Okay. So not to scale. What did I do? I wanted to erase it. So I already know how to graph cosine. And if you said, what does a graph of cosine look like? Well, it starts at the highest point. It goes down to the x-axis. Lowest point, x-axis. Okay, highest point. This is cosine. Can't even sketch. So, ladies and gentlemen, there's your cosine curve. But what in the world does it have to do with secant? Do you guys know what it has to do with secant? Well, cosine and sine are reciprocals. So what I want you guys to know is something like this, okay? If cosine of some angle, I know, okay, let's say x. If cosine of x equals, let's say, 1/2, you know what that means about secant? What does secant equal? 2. Is that true? You guys okay with that? And if cosine is what? 0. If cosine is 0, what's secant? Undefined. And you say, why? Because you can't divide by 0. Is that right? You're saying this is 1/0. Well, that's undefined. If cosine is 1, then what is secant? 1, because they're reciprocals. Okay, just want to let you guys know. Now, here's my point. If they want you to graph, I don't know what color we should use. Pink? Yeah, let's use pink. Stands out. If they want you to graph secant, you know what you guys do? Every point on the cosine curve gets what? It's not, well, what happens you take the reciprocal. Here's what I mean by that. Here's what it's going to look like. The reciprocal of 1 is 1. The reciprocal of this number here is now what? Up here. The reciprocal of this number here is now what? Up here. In fact, what you're going to see now is that all of those points in pink are going to go up like this forever. I'm going to have to undo that. You're going to have a vertical asymptote at pi over 2. Similarly, all of these points get what? Have the reciprocals as well. The reciprocal here at -1 is -1. You're going to go down like this forever as well. Okay, you guys with me on that? This is what's happening with all these points on this curve. These points, you're going to have reciprocals. At 3 pi over 2, you have another vertical asymptote. So all those points get reflected as reciprocals. Same thing here on this side here. So in pink, ladies and gentlemen, we said, wait a minute, I mean, all my points here in blue, we take the reciprocals and now they're above? Yes. What I'm saying to you is, this is the famous graph of secant. Okay, you guys okay with that? That's what secant looks like. Now, let's go to Desmos, okay? You may not believe me. You say, wait a minute. Yeah, if I say, can you graph cosine? Let's do that here in Desmos. And remember that interval of one cycle is 0 to 2 pi here. So we say here 0 less than or equal to x less than or equal to 2 what pi. Okay? That's cosine. We want to look at the reciprocal, which is what? Secant. From the same interval of one cycle. 0 less than or equal to x less than or equal to 2 what pi. Okay? You guys see my point? Isn't that the exact same what? Situation that I just sketched? I'm going to put cosine here dotted. So when you graph secant, what's the key? Graph sine and then sketch it this way. Where you have x-intercepts, they're now going to be your what? Vertical asymptotes. So what did we say? Was it pi over 2? And what was the other one? 3 pi over 2. So your x-intercepts now become, ladies and gentlemen, vertical asymptotes. I want to change you. Change you lines. Okay. And I'm going to get rid of the cosine curve. Because the cosine curve really isn't here. So what you guys are actually looking at is the standard graph of what? Just secant. So I want to remind you, how do you graph secant? Graph cosine and then make your x-intercepts vertical asymptotes. And then you could take that reflection that we're seeing there. And you say, is that the same thing for cosecant? Yeah, but you have to graph what? Sine to get the graph of cosecant. Okay? These are what's known as the reciprocal functions. So on my website in blah, 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 where are we at here? Okay. Let's see if this is working here. The wireless on the campus. Jeez. There we go. Somewhere here. Where are we at? The wireless on the campus. This one was fine. See this here? This is titled graphing what? The reciprocal functions. This is graphing secant and cosecant. So the key, like we just graphed secant, but the key is to graph your sines and cosines the same way. And of course I put some what here? I put some solutions for the what? Solutions for the evens. And, you know, I might do some solutions here for you guys for the odds as well. But anyway, I wanted to leave you guys here. If you want to get started on graphing what? Secant and cosecant, then you can. It's all in Canvas, is right? Did you guys see that in Canvas? So I just want to let you guys know you could get started. But if you said, I want to see more detail because I want to get started, what could you guys watch? Is there a nice video there for you? Yes, if you want to get started on that, okay? You guys okay with that? Anyway, let's see if this video